As we know, how can we find out the polar form of complex number? Now here we will discuss some cases and we will try to find out the polar form of some different forms of complex number. So the first case we are going to discuss, that is to find polar form of purely real complex number. So let Z be a purely real complex number. So Z is equal to x plus eta 0, where imaginary part is 0. So here comparing Z is equal to polar form, that is R cos theta plus eta sin theta. Therefore here x is equal to R cos theta and y is equal to R sin theta, that is y is equal to 0. So from here we get cos theta is equal to x over r and sin theta is equal to 0 over r, that is 0. So what is the value of r? We will get r from the value of adding x square plus y square, that is a modulus value. So we get mod x square, that is mod x square under root, that is mod x. It is always positive, so it is x. The value of r is x. Therefore, there are two cases when x is greater than 0. Then cos theta is x over r is mod x, that is always positive, and x is greater than 0, so this x is positive, so we get 1 and sin theta is equal to 0. So as sin theta and cos theta both are positive, that is theta lies in first quadrant. And we define sin alpha mod 1 is equal to mod 0 is equal to 0 and cos alpha mod 1 is equal to 1. That is alpha is equal to, when sin alpha is 0, 0 and cos alpha is 1, then angle is 0. So alpha is 0. Then theta is equal to alpha, that is 0. Therefore, when x is greater than 0, then z is equal to x plus eta 0 becomes value of, that is r is here x cos of 0 plus eta sin of 0. This is the polar form when x is greater than 0. Now the second case is when x is less than 0. Then cos theta is equal to negative x over x, that is negative 1, and sin theta is equal to 0. As cos theta is negative and sin theta is positive, therefore theta lies in second quadrant. Here we are going to define sin alpha is equal to mod value of 0, that is 0, and cos alpha is equal to mod value of minus 1, that is 1. So here alpha is equal to, when sin is 0 and cos is 1, that is sin is 0 and cos is 1, that is 0. Now as theta lies in second quadrant, therefore theta is equal to pi minus alpha, that is pi minus 0. Therefore, theta is equal to pi. So when x is less than 0, so mod z x plus eta 0 in polar form is x into cos pi plus eta sin pi. So when z is purely real number and value of x is greater than 0, then it is x cos 0 plus eta sin 0, and when x is less than 0, then it is x into cos pi plus eta sin pi, or when x is greater than 0, that is we get z is equal to x into cos 0 plus eta sin 0. So it was all about the polar form when z is a purely real complex number. Now the next topic is to find the polar form of purely imaginary complex number. So let z is equal to 0 plus eta y be a purely complex number. Here x is equal to 0 and y is equal to y. That is r cos theta is equal to 0 and r sin theta is equal to y. So cos theta is equal to 0 over r and sin theta is equal to y over r. So here we get cos theta is equal to 0 and sin theta is equal to y over r. So what is r? R is the modulus value, that is under root 0 square plus under root 0 square plus y square, that is more under root y square. We can straightway write it as y, as r is always positive. So in this case we will discuss when y is greater than 0. Then cos theta is equal to 0 and sin theta is equal to y over y, that is 1, because y is greater than 0. So in this case cos and sin are positive, that is theta lies in first quadrant. That is, we can define sin alpha, that is mod 1, that is 1, and cos alpha mod 0, that is 0. Therefore alpha is equal to pi by 2. Therefore theta is equal to pi by 2. Pi by 4 only, so pi by 2 here. We have sin alpha is equal to 1 and it is at the angle of pi by 2. So theta is equal to pi by 2. Therefore, when y is greater than 0, polar form z is equal to y 0 plus, that is cos pi by 2 plus eta sin pi by 2. That is the polar form when y is greater than 0. What happened when y is less than 0? So in this case, cos theta is already 0. Sin theta becomes minus y over y, that is minus 1. As sin is negative and cos is positive, theta lies in second quadrant. Therefore, we define cos alpha, that is 0, mod 0 is 0, and sin alpha that is mod minus 1 is equal to 1. So, as cos alpha is 0 and sin alpha is 1, therefore, theta is equal to alpha is equal to, that is pi by 2. Sorry, here we have just think here cos theta is 0 and sin theta is negative, not cos, sorry, it lies in third quadrant. It lies in third quadrant. So, theta, alpha is same, alpha is not depending on this sign, alpha is depending on the angle. What is the angle? Angle is, value of angle is 0 and here is 1. So, alpha is pi by 2 here. As theta lies in third quadrant, therefore theta is equal to minus pi plus alpha. That is minus pi plus pi by 2. That is minus pi by 2. Therefore, as y is less than 0, argument of z is minus pi by 2. So, when y is less than 0, polar form of z is y cos of minus pi by 2 plus eta sine of minus pi by 2. So, when y is greater than 0, so polar form is y cos of pi by 2 plus eta sine pi by 2. But when y is less than 0, its value is y into cos of minus pi by 2 plus eta sine minus pi by 2. So, this was all about the polar form of imaginary complex number. Purely imaginary complex number.